Hey, welcome back to Math with Patrick. Today is January 21st, and of course we're solving the 21st problem from this Daily Epsilon calendar. Let's try it out. Let's see, the answer today is 21, because that's today's date. And we're supposed to find the count of integers where n squared minus 101 is negative. I'm assuming that this n right here is going to be one of our integers. And the idea is that we should just plug in some integers here, evaluate this value, and see whether or not it's negative. If it's negative, then we'll add something to our tally, and we'll keep tallying it up until we reach, well, probably 21. Now, I do want to be a little bit strategic about this because listing out 21 things doesn't sound the most fun. So I'd rather create a range of values instead of like counting literally every single one. I know that when you square something, it's always going to be non-negative. I was going to say positive, but it's always going to be non-negative. That's because if we take a negative number and square it, that means negative 2 times negative 2 in this example, it's going to be positive. And if I try squaring a positive number, well, a positive times a positive is still a positive number. The only time that this is not positive is when we square 0. In this case, 0 times 0 is still 0. But the important part is this number is never going to be negative, or in other words, this negative 101 is the only reason why our n squared minus 101 is negative. This value is always going to be 0 or greater. And I know that when you square numbers, at least square numbers larger than 1, they'll grow or get bigger. And that means eventually n squared will be bigger than 101. Eventually this will be positive. So I want to know this break-even point. What's like the largest integer I could put here such that this is still negative? And actually, it's not too hard to find. If n equals negative 10, or if n equals positive 10, I can square negative 10 here and subtract 101. That's the same as 100 minus 101, and that is still negative, but barely so. If I try plugging in 11 or negative 11 here, I'll get 121 minus 101, and now that is positive. Oops, not 120, but just 20. So negative 10 and positive 10 are respectively the least and greatest integers I could plug in and still get a negative value out of n squared minus 101. All right, so I just made a table to kind of succinctly share my thoughts. Here, if we plug in that negative 11 or positive 11, our output is positive. And so here are the only times where n squared minus 101 is negative. And all I got to do is count the number of values of n between negative 10 and positive 10. And so when you're counting the amount of numbers between two inclusive, you just got to make sure that once you find the distance between the two, you add on another 1. And I mean, hear me out. If I ask you how many numbers are in this list right here, you'd say 2 of them. But if you just do top minus bottom, you'll only get 1. So if I have a list like this, and I ask you how many are there, you can see 4 of them. But then again, or once again, if you do top minus bottom, you'll only get 3. So if I'm counting the amount of numbers in a list, and they're in order just like this, I could do top minus bottom, but I do have to include this plus 1. All right, 10 minus a negative 10 is 20. Or in other words, if you minus a negative, it's kind of like adding. And then I can see that 10 plus 1 is 21. So pretty simple problem today. Thanks for coming along. And actually, hold on. I want to do a short little epilogue, just solving this problem with graphing instead of with tables. So I could have also solved this graphically. Here I'm writing a function of n squared minus 101. If I zoom out, I can see that I have a parabola. Anywhere below the x-axis is negative, and so I'm just double checking where is the value negative. It looks like it's always negative all the way up until just a little bit below negative 10, and just a little bit above positive 10. And just like with the table and plugging in numbers, I was able to figure out through graphing now that 10 is my greatest integer and negative 10 is my least integer. And I could even look at the graph and count them one by one if I really wanted to, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and get to 21 once I get over here. So you could also use a graph or use a visual to help you out and find the answer to this problem. So we're all done now. I just wanted to show two separate solutions in order to figure out those high and low values for n. Okay, we're all done. Bye-bye. I'll see you tomorrow.